I would like you to perform a real-life application of the Ensemble and hybrid applications to achieve better result. Yeah, well, when we talk of Ensemble approach, I believe that we have a couple of demonstration on this. So we will, because of time, we will refer our members to check out videos on Ensemble techniques, how we can build Ensemble techniques. And the idea of Ensemble techniques is in line with the usual system of life, that when you have, we call it committee of people. The basic principle in life is when you have collaboration. So we have 1, 2, 3 people taking decision, even in real life. You want to visit medical doctor, you visit one, you get the opinion of the doctor, you get the opinion of another doctor. Human being like this kind of idea. You want to be sure that, okay, the advice given by one doctor is being reinforced by another doctor, by third doctor, fifth doctor. If all of them agree on the same diagnosis and recommendation, then you are likely going to be comfortable going ahead with the treatment. However, if they keep contradicting themselves, then you might have to seek for more doctors to actually give you opinion. So by the time you finally arrive at the final decision, one, you are more comfortable and they are likely to be correct prognosis and outcome of such system. So in what we call, when you are united together, we can solve a better problem. And that is exactly what Ensemble is trying to do. Here you are going to train several machine learning algorithms and then use the same data or in different way of partitioning it to solve it. And then they have different type of ensemble. It might be voting. So you train like 50 algorithms of 155 algorithms on a product, and then on a data set, and then you ask them to predict. So majority gathers the vote. We also have stacking, another assembly approach. And in real life, it has been demonstrated in a lot of application competitions. The winning teams are always using Ensemble, because if the data is complicated, it's very, very non-linear and highly unpredictable, you might not be able to achieve the needed accuracy. For example, one of the very popular examples in this was, there was a time Netflix brought out a competition that if anybody can improve their recommendation system by 10%, just 10%, only 10%, they are ready to offer $1 million to that team that does that. People tried, they were able to get 70%, 7% improvement, but no one get to 10%. So toward the end of the competition, the teams had to come together, all of them, different teams from different countries. They now try to combine their result into an ensemble, and they were able to achieve 10%. So when you have, of course, you don't go to ensemble right away, because ensemble has its own problem. At a point in time, you might not be able to explain what is really happening. The explainable AI becomes confused because you have done a lot of mixing and mixing and mixing. But when accuracy is what you want, then you go for it. You see, if explainability is what your client wants, then they might have to compromise on the performance so that you can be able to explain. But sometimes we want accurate one. We want to take decision when there is going to be maybe an earthquake on an hurricane. We are more concerned with precision. We don't care how that precision is gotten. Give us result that doesn't make any mistake. So there are some areas that precision is what we want. How do you mix them together? Which variables are responsible? We don't want to care, but we want 100%. No mistake. In this case, we go for ensemble because they have been proven to always generate super excellent results in the face of very tough data set, as the case may be. So like I said, I would recommend that we check out our video. We have several videos on ensemble, and we took it gradually, maybe more than 4 or 5 video sections, if not more. We have a lot of question and answer section, demonstrative video. We haven't had a video that discussed and demonstrated how we can build ensemble in weaker environment. Yeah, we also demonstrated it for us. But again, we don't go, if you are, the principle of machine learning is to keep it simple. You start with simple algorithm first. if you are getting with KNN 100% or 98%, 99%, then you don't need to go to Ensemble just for the sake of Ensemble. So, however, sometimes no matter what you do, you are just not going 75%, 85%, and you want more, then you might have to start thinking of Ensemble because it's going to take you more time to build. Then at the end of the day, explainable AI might not be able to explain how the result is coming out because precision is what it is centered on.
I have two questions. So the first one is that, in the tech industry, when people are building solutions for using programming language, machine learning, sometimes they look at a particular area and they provide a framework. A framework not showing that that framework look at a problem in a particular area, and they provide a framework in form of programming language that we some developers just go online, get the framework, and use it to solve the problem. So I want to ask that, is it possible, like in the case of AI and machine learning, where, for example, in this area of agriculture, the tech industry can sit down, they can look at the problem of agriculture and bring all the necessary framework, all the necessary models properly trained together and build such a framework in such a way that people just plug in that framework. So the other developer just plug in that framework and use to solve agricultural problem in any means. Then the second question, is it possible for some guys, for some people to sit down and come up with an idea of just focus on data processing rather than going to, data processing and building AI model is also a two complex things. Is it possible for some people to sit down and focus on data processing, just to focus, get data and process data based on the requirement from the tech who want to build the models, so that by the time they want to start their own building model, working on the model, it will be easy for you. They won't be working on the data and also building the model at the same time. That's the second question.
There are a lot of opportunities here. Let me start from your second question or even first question. Yeah, number one, this idea actually is a very AI itself is a multi-billion dollars business opportunities. The sky is the beginning. So many things that could be done actually. If we are a few days ago, there was this LEAP 2024. Maybe some of us might be aware of it. LEAP, LEAP 2024 in Riyadh, Saudi Arabia. We had thousands of people from all over the world converged, showcasing their startups here and there. Something unique there. I was opportune to be there for a couple of days. Something unique there was that most majority of the startups, they have AI or whatever as part of their component. AI for this, AI for this. These are even very simple ideas sometimes, and you see people coming out for it. You see investors putting in millions of dollars on it. Oh, go ahead, we are convinced about this. Go ahead, we are convinced about this. So there are a lot of possibilities. People can come up and build systems that will be made available readily for farmers to be used in different aspects of, we have just listed some of the possibilities in our 3 videos now. This is the 3rd week we're talking of crop production, and the list is still more. Even one aspect of it, someone could take it and look into it, check out is somebody already doing it, very important, and then a team could be formed, and then they can come up with a kind of a small work in that area, which can become startup. So then to think even bigger, that I would say even subsection of it, 1 or 2 things could be combined together, integrated for possible increment later on. And a very big framework, as you said, can also be built. If no one is doing it already, we have to check the market and see who is there already. And then there is a lot of opportunity in this sense. That is, people can come up to my answer will lead to the second question of, can you have a separate system, a separate set of people that will be specializing in data, another one will be building it? I'll come to it. However, in the first question, like I said, there's possibility there. We have to keep thinking about it, thinking big, either solving a small aspect of it or coming up with something really very big. Of course, that's going to take time, and get it to market It's very important. Being the first one to think about this idea and go to market with it make a big difference, actually. And that is what the tech companies are taking advantage of. When Google came, Google Map came for free. People were just using Google Map to travel here and there until Uber came, this transport company, and look at it. Wow, we can take advantage of this. The rest is history. They have, without having any car, they have $1 billion investment and lots of money be made every day, because it's just a matter of integrating a similar software on top of the Google Map and other mapping systems that are available. And you can call them, I want to travel here, I want to go here. This is how actually the fintech industry actually are building upon lots of opportunity. Look at an area that people are not really looking into critically, and then try to see what could be done to make life easier for the people. And that is service provider. Now, I hope that clarified that question. On the second question, yeah. See, the concept of called data science. Hopefully we have opportunity to talk about data science proper soon, so later on. See, data science is when it has to do with data, modeling, manipulations, and the likes. We use machine learning to support data science, but machine learning is not data science. So data science is a bigger concept. We can do data science without machine learning. We can use statistical method and so many other clarifications. Later, we're going to make for ourselves. However, data science or machine learning solution provider need to come up with a whole team has to do that. It's not that, okay, somebody will work on data, another person will work on another company will work on the production or the development of the modeling. You know, there was something we used to show to ourselves that machine learning modeling is iterative. You start with data. This is data preprocessing. Then you move to modeling. Then you check the performance, call it evaluation and performance. You might have to go back here to improve the modeling, doing hyperparameter optimization. Sometimes you might have to go back to the data, even data collection. Sometimes before preprocessing data, we have data collection. Sometimes you might have to go back to the data collection stage. So this is why actually any data-driven modeling or system building has to be team-based. This is highly recommended. You can't do data science system alone. It will be too much for you that you'll not be able to finish in a timely manner. And you know time matters. Time is life. If you don't deliver it to your client at the appropriate time, they will lose business opportunity. They can even take you to court because they already pay you for that. So you develop this in team. So there could be part of your team member who are specialized in data collection, data preprocessing. They're part of your team, the same organization. Because you might have to go back to them quickly. So if it is separated from outside, external source, then the delay is good. There's going to be delay in the procedure you're using. So we have a separate company that is doing data processing. Another one will just get the data. Because sometimes things don't work out. So that's why this iterative procedure needs that the team, they are kind of in-house. They are connected together. You are responsible for this. Once you are done, you send it to the modeling team. Modeling team can quickly call on you because you are a team. Meanwhile, the moment you are done, you go to another project and start analyzing the system. But if they notice the problem, they can easily call upon you. Hey, please come back again and do that. So if they are far away as a team member, it might be difficult for them. But then, of course, agile process, new technological advancement in collaboration might make it also possible for even people across teams. They might be able to work together. But the best way is in data science and machine learning, data-driven solution development. It is highly recommended that it should be a team-based development to make it faster and you're able to achieve the result as soon as possible. So this could be, again, the idea of totally separating them because data is closely connected with the modeling you want to build. And there's going to be a lot of going back and forth. You might have to go and collect another data set and then as the case may be. So that's why in most cases, data science-based companies, they're always self-contained. They take the data, they have experts on data analysis, they have experts, that is their work, but they're going to be part of the team rather than let it be under outside system. I hope that clarify your points.
Irrigation model. So what are other parameters, other evaluation parameters that need to be looked out for, apart from the correlation coefficient and RMSE?
Okay. Well, if you are working on regression solution, if you are solving regression problem, a root mean square error is very, very important, for sure. For correlation coefficients, though very important also, but however, correlation coefficient alone cannot tell us your result is good or not, because sometimes you can have negative correlation. It means that their input is the original is increasing, the target value is increasing, the prediction is reducing, and you may still have high correlation, but then the values are not close together. But root mean square error will tell you the actual errors in between them. So aside this, another thing that after all these parameter measures you have given to you, you need to make a plot for regression. Make a plot. See?
Okay.
Yeah. On the same plot, XY, you're going to plot both the predicted value and the actual value, the one given to you. Put them on the plot.
Okay.
So when you put them on the plot, the advantage there for you is that, okay, let's say you have here. So start my legend. This is predicted value. So 0 is original actual value given. So when I plot it on the same graph, these are the original given actual value given. Then my predicted value like this. You can see it. So when you make this kind of scatter plots, we can visualize how far your prediction is away from the actual value you have been given. So because when this is very, very important actually. Reviewers always like this kind of idea because sometimes also people show it in table. You can have a table in your report whereby you have predicted value here, actual value here. You list them down in number. So people can look at it. Instead of 26.5, you predicted 26.4. Instead of 35.5, you predicted 20. We will know that this is far away from this. So they put it in table. If the values are not many, if that maybe 35, 45, it's okay. But if small, you can plot a very simple plot. We will see that, okay, you are very closer together. So it's a very good addition for you to include in your analysis.
Okay. Thank you, Doctor.
You're welcome. So, and another thing also there is when you do that, it's always good also to look at literature. Check out the literature in that area. Whatever they have used before, it's good to also use it in addition to all these kind of new ones, maybe you are just coming to know. So, yeah, you need to use whatever they use in addition to that, because some areas, they vary. There's, for example, if you are predicting software efforts development, there are some special, they call something PRED 25. There's some quarter percentage I want to ask you to calculate. So you look at the literature, then you follow whatever people are using so that you can compare your work with them appropriately. So thank you for that.
Right, thank you very much, sir.
Yeah, you're welcome.
Okay, Prof, there's a question on the chat box.
Okay.
And I think it's coming from Mr. Ibrahim, and was saying it's a mechanical, although he said he has issue with his mic.
Okay, I got it in. Thank you very much, Doctor. Yeah, sorry, my sister. Sorry, my sister mic is not okay. I have a question. I'm a graduate of mechanical engineering. My focus area is automobile engineering, which I have practical knowledge of it. I have interest in getting adequate knowledge of machine learning so that I can perform well in my postgraduate study, which I'm studying. which I'm interested in studying the application of AI and ML for automobile engineering, like self-driving and extensive application. Okay. What advice can you give on your route you think I can take towards success? Well, you're welcome, and I wish you all the best, your aims and aspiration. So the starting point for you to also start, because your background is not computer science, so yeah, start learning machine learning. So as you are in this kind of forum, and there are several other forum, of course, but here I specifically start using what I call no coding AI. So no coding AI, because we want people to take advantage of it. No coding AI. It's an idea we started a couple of years ago, and now even top universities, including MIT, are starting special courses on no coding AI, because a lot of people, they start training on how to use machine learning and they run away along the way because the coding is a little bit tough for them. So what I used to say, there's difference between coding and AI. There are two different things entirely, and other AI, machine learning, and the likes. So they're totally different concepts. Now starting with, so the fact that you don't know coding should not make you not to be able to advance in your AI and ML aspiration. Of course, once you are comfortable with machine learning concepts. So the first thing is, while learning the concept, don't bother yourself about coding, because it is not coding. There are different concepts. So even sometimes when I teach undergraduates, yes, they know coding. Some of them are struggling with the coding. I say, hey, forget about the coding for now. Understand the concept and then come back later and do the implementation later. Because if you are struggling with coding and struggling with concept understanding, you lose it and then people lose interest totally. So if you can do it without coding, then why making it compulsory for you at the beginning? Of course, later on, we have a lot of free source, like try to learn Python. For people who have that interest in it, you have to go into learn Python, and it can use MATLAB is also there. That's why if you have even talked, that's why I don't really talk much about coding, because there are different programming languages. You might get a job today, you know Python, the company say, no, we don't program in Python, we use R. It means you have to go and learn R again and then use it, which is easy to learn if you know programming. But the most important thing is the concept of that AI and machine learning. Once you understand the concept, you can learn programming and then use it. And most of the programming languages they're using, there are a lot of libraries you can just pick. Once you know programming, and then you can utilize and deploy appropriately. So in short, we focus more on understanding the concept, because I know many people are from different backgrounds. Medical doctors are here, mechanical, civil engineer, metallurgy engineering, and so many. And some of them are not having background in AI. There's no problem in that. So focus on learning. You are welcome to our platform. Check out our, what do we call it, our YouTube channel. I think one of the admin already posted it there. Check it out. We also have what we call channel watch guide. So that we have over maybe 147 videos already uploaded. So sometimes it could be overwhelming. Where can I start? So the idea is there is a guide. We have a guide. So it will be posted for us. If you are not in the WhatsApp group and Telegram group, you can contact our admin there. Professor Tijani is there, and also Dr. Mujisola Tajuddin. So you can contact them. They will add you to the WhatsApp group where you can get updates. You can get a copy of the watch guide. It started by saying, if you are new, these are the first few videos you should watch. By the time you start watching it, then gradually you move towards implementing it in weaker environment. Then once an interest is built, you have understanding the concept, then you can then move on appropriately. So since you are mechanical, you can go ahead with your postgraduate studies in mechanical, focusing on the automobile. However, you are going to be machine learning and AI biased when it comes to your thesis, or when you're going to be doing projects during your course. So start small, get data online about anything related to your area, and start implementing some of the little AI system you are be talking about. Once you get comfortable, then autonomous driving car and so many opportunities you are interested in can then follow. So, and it's an area that is very interesting. Anybody can use it. So a lot of new systems are building, no coding concept, just drag and drop. You build a very powerful machine learning or artificial intelligence applications. Pending the time, then you can then learn coding later if you want. So, but things are now getting really, really easier that you can build and deploy machine learning algorithms, machine learning model without the coding stress that often scares people away from learning this very interesting concept. Hope that answers your question. So, and you're also welcome later to get across for further clarification.